using the diagram below, or actually beside, name the following. Name a radius. Well, there's a couple of them in here. How about HA? There's another alternative where you could say AF. I believe those are the only two radii listed. Name a diameter. Well, diameter, remember, has to go through the center and has endpoints on the circle. So the center of the circle is A, so our diameter is HF. Notice that I'm naming the endpoints on the circle. Letter C. Name a chord that is not a diameter. Well, chord still has endpoints on the circle, so an example of that would be BD. Name a semicircle. Well, the semicircle has to have endpoints from the diameter. Remember that arc shows that it's a semicircle. We're going to use 3 letters, and you could do something like H, G, F. Another option is to say H, B, F, or even you could say H, D, F. But notice how all 3 of those have the endpoints that are coming from the diameter. A minor arc only has 2 letters to name it. It needs to be less than 180 degrees. And I use BD. Not the only choice, but it's a good one. Major arc needs to be bigger than 180 degrees. So I'm going to do HBG. Again, a major arc has 3 choices, 3 letters, sorry. And it needs to be bigger than 180 degrees. And finally, a tangent line. Well, a tangent line is going to really be a line that's outside of the circle and only touches the circle once. And in fact, I already have a point at the point of tangency right here at H, but that line is BJ, and it's a line. Use the diagram of the circle below to answer the following. Leave your answers in terms of pi. Well, remember, on your green formula sheet, you will be given the formula for circumference. And that formula is that it's 2 pi r. That's the formula that's on the green reference sheet. So over here in our circle, we see that the radius is 11. And when we fill this in, then our circumference is going to be 2 times pi times 11, which ultimately is 22 pi. If we do look at units, which I'm not going to be super picky about, I am going to put them in there. Inches. Letter B. The area is also on your green reference sheet, and the formula is going to be pi r squared. And we already listed what the area was, or sorry, the radius is, and this is going to be pi times 11 squared, and 11 squared is 121 pi, and area is measured in square units. If we want to find the length of arc Z, we're going to be using our proportion, and so the length of RZ, YZ, and actually that is a typo. Let's find the length of RS here. We'll fix that. The length of RS is going to be determined, I'm going to call it X, by X over the circumference. Well, if we look above there, we see that the circumference of that is 22 pi. And that equals then the value of the central angle, which is 65 degrees, divided by a total of 360 degrees in the circle. And actually, the central angle is 65, so the intercepted arc is also 65. But then what we're going to do is we're going to cross multiply, and remember to use Desmos or your calculator. But this gives us 360x, and then we're going to take 22 pi, and we're going to multiply it by 65. So I have the calculator here. 22 times 65 is 1430. So we get 360x equals 1430 pi. And if I look up here at the directions, it says leave your answers in terms of pi. So I'm going to divide both sides by 360. And what we end up with here is we take 1430 divided by 360. Gives us that decimal there. I actually, on my answer key, did math, enter, enter, and I wrote it as a fraction. But there you can see the decimal at least. I'm going to write 143 over 36 pi. And I got to go back and look at what that is again. Over 36 pi, and technically it's inches. If we look at finding the area of the shaded region, we're going to do the same sort of calculation here, only what we need to do is we're still going to do x, and you can see here, probably a little bit better than what you can see on your paper, that kind of that little triangular piece, and it's not a triangle, I don't want to overlook that fact, but it's this entire part, that's what we're finding, and we're going to use the area. So our denominator, the bottom of our fraction here, is coming from the area, which is the 121 pi, and it's still then going to be the 65 over the 360. So the measure of the central angle, or its intercepted arc, and we can cross multiply once again, and we get 360x equals, well, let's go type it into our calculator, 121 times 65 gives us 7,865 pi. Again, the answer does say to leave it in terms of pi. We can divide both sides by 360. So 7,865 divided by 360 gives us this decimal, which is not very nice. So again, I converted it into a fraction by hitting math, enter, enter, and we get 1,573 over 72. Pi. Inches squared.